Okay guys, so we're just going to finish up our presentation today, and we're going to finish up our object header part, and we'll be looking at object header examples. And when it comes to the whole message interpretation, I would say this is probably one of the most sort of complex or difficult parts, especially when it comes to the object header in responses. And furthermore, when it comes to object headers and responses, you have data that's coming back from each and every point in a response, and each and every object group and variation is formatted differently, and you need a whole other document in order to look it up to understand it. So we're going to try and keep it as simple as possible, but at least give you some kind of understanding as to how this all works. So we're working with the object header. So that's this part of the message for any request or a response, and it's comes right after the application header in terms of interpreting the message, like we have, starting at the top and working our way down and working left to right. The thing is when we have a response, there's a varying data field in here that's all dependent on the object group and the variation and the number of points and things like that. So that's where things become pretty complex. And I talked about how in this course we really only go as far as the first object header for a response, and understanding essentially how to use this tool, that is the breakout sheet, to interpret it. So when it comes to the object header, aside from the obvious object group, which is one that is corresponding to a data type, and you just look it up in your object library, or the object variation, which is the specific variation or flavor, if you will, of the group or of the data type, then what we have is the qualifier and the range that is the last part of the object header. And this is where I've told you, don't even bother looking at anything other than this table right here. It's kind of the same thing when we're working with the data link control byte. We're just going to go directly to this table and it'll answer everything we want to know. But when it comes to the qualifier and range in the object header, just go right to this table right here. And you'll find everything you need to know there. So just wanted to make sure you understand when we go into these examples, you can use this table alongside it to make some sense of that. So here we are at object header examples. And in your breakout sheet, or on your breakout sheet, you'll find this table. And so you probably want to be looking at this table from time to time as we look through these examples. Okay. So the first example we're looking at is from a request. Okay, now in a request, that's a message being sent out from the master to the server, or from the master to the outstation, requesting to either read, write, freeze, or take some kind of action upon an object. And it could be even action upon a device, like to restart it or reboot it and things like that. So it's where all the functionality is coming from the application header, and now this is where we're actually looking at the objects themselves and what's being accessed. What's the object that's being accessed, and how is it being accessed? So if that makes any sense, then let's take a look at this first request object header. So there's the first object header we see in this request. And if you look at the hexadecimal information that's given in that request, it starts out with a 1-byte object group. So here we have a 1-byte object group. That 1-byte object group in this case is 0x3c. So now we convert that to decimal in order to look it up in our object library, and we would see 60. So that means object group number is 60. So you're looking up object group number 60 in your breakout sheet. Then you move on to your object variation, right? So that would be 0x02, which equals 2. and equals variation 2. So we're looking at object 60 variation 2. By definition, using your object library, you can see this is class 1 data. So what is this? This is event data. If you look it up, you'll see it's event data. And it's what we would say are one of the most important events because of the way that we classify these events as class 1, 2, 3. So that's what we're looking for is event data with this first object header. And we are looking for class 1 data. Now we move to the qualifier. So for the qualifier, we see 06. So if we go back here, what do we see for qualifier 06? Here's our 06 qualifier. It's indicating that it's all points. And notice how it's only going to be found in a request, and a request is what we're looking for. You won't find it in a response. So for a request 06, it means that our range field is 0 bytes. So there is no range field. So if we go back here, notice how it says 06 is all points and no range field. So what it means is if there's no range field, we're just going to go directly into our next object header. So this is our first object header that we just looked at. There's no range field. There's no data points because we're looking for all points. So there's no list of points or anything like that. And we follow directly up with another object header, which is our next one that we see there. Okay. So if we follow through that whole request, you can see we've got the first one that we looked at, class 1 data, all points. We look at the next one, it's another 3C value, which we know is 60, but in this time it's variation 3, which is class 2 data, and a 06 qualifier again. So that's all points again, and there's no range field. Goes directly into the next object header. 3C again, object 60, except variation 4 this time. Variation 4 is class 3 data. And then lastly, you end up with the very last one, which is object 60, variation 1, which we know is class 0. So this is all the static data, or what we know is real-time data. So this would be a class 1, 2, 3, 0 poll, which we know it has another name that we call an integrity poll. Okay, so these are sent out regularly to retrieve all events and then keep the real-time database synchronized with the far end, making sure that no points are lost or out of range or offline when it comes to your real-time database. So this is called an integrity poll, and that's what we see going on here. So if we take a look at a few other examples of different qualifiers, we see some other examples that could be leveraged in a request here. Notice how we're still doing a class 1 poll here, but instead of a 06 qualifier, we have a 07 qualifier. If you go back, you see a 07 qualifier is indicating a 1 byte quantity. So the range field is going to have a 1 byte quantity in it, and the size of the range field then is going to be 1 byte because it's just a 1 byte quantity. So if we go back here, we can see qualifier 07 is saying what's going to follow is a 1 byte quantity, and here we're asking for 8 events. Here's a 1 byte quantity, and it's looking for 8 events. Okay? So that describes a 07 in a request. Then we go to 3C, which we know is 60, a variation 3, class 2 data, and here's another 06, which is no range field. So there's going to be no range field here, and we're going to go directly into the next qualifier, 3C, 04. You can always slow down this video and review your table if you want. But now we see a 08 qualifier. Now this is one we're going to look at a little bit more detail. This is just like the 07. It's just like the 07 that we saw here, but now it's a 08, which says this time the quantity of points we're going to be looking for is going to be expressed as a 2 byte value. Okay, So that obviously means that we're looking for more points than can be handled with a single byte, or 255 points. So if we go back here then, what do we see? We see a 2-byte value that's indicating 2C01. Of course, that's the raw value, but that's a 2-byte value, isn't it? So because it's a 2-byte value, we know we need to change it to flip it, right? It's got to be flipped. So that means that's 01 2C. Sorry guys, that's 0x01 2C. So if you take that value and put it in your calculator as a hex value and convert it to decimal, you're going to find 300 base 10. So remember I said that all 2-byte values are flipped from the way they appear as a raw message in order to interpret them. So here's a perfect example. A 2-byte quantity, we know it has to be flipped before you interpret it. Okay, here's where with responses it becomes a little bit more complex, and so I'm actually not going to spend a lot of time on this because I would say it's kind of, particularly this year, outside of the scope of our course, but we'll just keep it pretty simple here in terms of explaining a few things. Now this is a response. This is a response that's going to include point data. So if we look at this object group 33 and we convert it to decimal, you would see that that is object group number 51. So 51, we'll be able to look and we'll see its time and date CTO. And then if you were to look at your object variation, you'd be looking at object variation 1 for object group 51. So that's describing the data and its the data type and its variation. Then you have the qualifier, and that's what we're looking at here. That's it's saying 1 octet here. Remember, octet and byte mean the same thing. So this is a 1-byte quantity. And so the range field is indicating that we only want 1 point. Thing is, what's going to follow is all the point data for that point. All the point data for an object group 51, variation 1. And so what you'd have to do is you'd have to look up that specific object group and variation in that binder that I talked about that describes all the data types and their formats in order to see how object group 51, variation 1, how each and every point is formatted to express this time and date CTO. And so that's where things become a lot more complex or complicated. And why would we need that in order to interpret a full response? Because that would be the only way we would know where the data block or the point data ended and another object header started. So that's the only way you know, is by looking that up in that document. So yeah, so that's just something to be aware of there, and something I've kind of talked about a little bit before. So we're going to keep it simple and just carry on, but you understand that 07 was saying, hey, there's 1 point of object 51 variation 1 to follow here. Okay, so that's qualifier 7. Qualifier 17, what does that mean? That means that we're going to be, with 17, looking at a 1-byte quantity of points, right? So if we look at object group 2, variation 3, we'll find it's a binary input event with time. And so this is some additional information that the only way you're going to know that is to look it up in that, that binder to know that it's going to take 3 bytes for each point. So that means if we look at what's going on here, we've got a qualifier of 17 that's saying the quantity or number of points that we want from this object group number and this variation is 4 points. So with 4 points, we would have 4 points to follow here, and of course we'd have to look it up in that document. So keeping it simple. Okay, what do we see here when it comes to this response for a qualifier 17? We have a 1 octet or 1-byte quantity. That number of points is 4 events. This is indicating the 1-byte index that's for each point. Now, again, the only way you would know how to parse this out is to have that document. So somebody's done some work here and done some parsing of this message in order to show you how it works. But notice how, in order to represent the point number, it's just a 1 byte index, it's called. And an index is a point number. So each and every one here is just a 1 byte value. The rest of it is the point data. So in here, that's all the point data. Okay, so that's really it, guys. I'm just going to go back to this as our final kind of wrap up. And here's our DNP request and response. Everything you see here for the request, you should be able to go through the process of interpreting every byte in this message. Okay, so that's something we're fully capable of doing. When it comes to the response, however, you should be able to go as far as right here in the message. So you should be able to carry on and do the full data link header, the transport header, the 4 byte application header, because remember, for a response we have a 4 byte application header. Well, for the request we only have 2. And then you should be able to interpret as far as the first object header. And that's it. After you've completed that, you've gone as far as we would ever go in this course, because after that is where you have point data, right? And having point data means that all these, the rest of this is point data with 2 byte CRCs to end every 16 byte data block. And the only way you can interpret that is to have that other binder or that document. And it becomes quite a complicated process. Okay. So that actually concludes our DNP presentation, and what we'll be following up with is practice exercises and ASE screen captures and things like that going forward that can really kind of help you practice using these tools and understand the scope of what we're trying to do here. So good luck, guys.